Okay, how does homeostatic mechanism work? It starts with, again, receptors. So receptors are the ones that are scouting for any type of what is happening on the outside as well as inside of the body. And they are the ones that are making sure that whatever it is, it doesn't deviate from the set point. So again, we talked about the body temperature. And if the receptors bring back information that our body temperature is higher or lower than the normal, then it will start talking to the effectors. When the effectors are activated, they will work really hard to respond. Okay, they will elicit a body response. And then, as conditions are returning to normal, effectors are gradually shut down. Okay, they cannot be turned on forever, otherwise it can't be good for our body as well. And that is known as negative feedback mechanism. So when the receptors turn on something, the effectors do their job, then they need to be turned off using this negative feedback mechanism, and it prevents from anything from going too far. So again, just repeating what has been discussed. First, we have a stimulus, and a stimulus or a stimuli is anything in the environment, anything that changes. And it would be picked up by the receptors. So we have receptors on our skin that will review temperature. We also have receptors everywhere else in our body. And then the receptor will gauge whether it is above or below the set point. And if it is, then it will start talking to the effectors. So for instance, the muscles or the glands, which will then cause a response. And so this is a very cyclic cycle. In terms of temperature control, we have temperature receptors all around our body. A lot of them are found in our skin. And we have a temperature sensitive region in our brain that dictates what the body temperature should be. When the temperature drops down, the control center triggers heat generating or heat conserving activity. So let me just highlight those. So again, when there is a drop in temperature, the brain will trigger heat generating and heat conserving activities. In terms of any assessment, so quiz or exam, you need to be able to explain what these activities are. So these activities include muscular contraction. So that's when the shivering happens. The shivering causes a production of heat. And then the blood vessels in the skin are signaled to constrict. So there is a constriction. So the blood vessels become smaller. And what this enables to do is that less warmth from the blood will flow out of it. Okay, so when you make the blood vessels smaller, it conserves heat that way. And that heat is retained in the deeper tissue. Now, if a person becomes overheated, there would be a different mechanism. And this will promote the loss of body heat. And so, first response would be perspiration. And perspiration has a cooling effect. That's also the reason why when it is hot outside, you mist yourself with water. It's the same thing. When the water evaporates, it has a cooling effect. Now the opposite happens. Instead of constricting, the blood vessels will become bigger or they dilate. And what this does, it allows for heat to be carried out, because when the blood vessel dilates, it is closer to the outer skin. The heart rate will increase, and this will send greater volume of blood. And as the blood is flowing, it's getting closer to the skin surface, heat is being released that way. There is an increase in breathing rate. Okay, so you're breathing faster, and this allows for the lungs to expel heat out of the body. Okay, again, when the body temperature is high, we start with the stimulus. And the stimuli is the body temperature being higher than the set point. And then receptors will see that, and specifically thermoreceptors, and they will signal the brain, the control center, that something is off. The brain will then signal the effectors to do what it needs to do in order to bring the body temperature back down. And again, that would be skin blood vessels will dilate, and then sweat glands will secrete perspiration. That is the response. And then this will continue happening until the body temperature goes back to the set point, which is 98.6 degrees Fahrenheit.